Hi everyone, this is Neil Bolger, and welcome to a Peak Loads QC quick review of VE-IES 2017. I'm going to go over a PDF report from the Virtual Environments IES software and give a quick way just to read that PDF for anyone that is having to QC a loads report and wondering what it is they're now looking at. So I have two different PDFs that I'm going to jump between, one that has no markups and one that does have markups that we'll end with. So this is the loads report you get out of VE-IES. It's very similar to other peak loads reports you may have seen on some of the pages. It includes a few introductory summary tabs for buildings as well, this being the first. So this tab includes information about the whole entire project overview. This is a building in Menlo Park. It's a core and shell spec office building. And so information that's useful in this tab to check, it tells you the square footage of the project, here 240,000 square feet. It tells you the heating methodology used, the heat balance method. It's the only one that IES actually has. It says information about the location, good to check that we have the right location. The design day conditions utilized, so we can see here the 99.6% for heating, 0.4% for cooling. We can go over what those mean in another tutorial later if you're unfamiliar with design day criterias. Some information on the temperature of those peaks and what month they peaked between. And then there's a little box down here that says project load summary, where it reports the cooling load peak and the heating load peak. Right off the bat, I'm going to tell you do not use or consider these numbers to be the entire peak of the building. These are without ventilation air and can be very confusing if you're trying to get a quick sense of the square foot per ton, the total cooling, the total heating, things like that. For those types of numbers, you should really go to the second page, where by default, when you run a loads report, there is a chilled water and a hot water loop for the building. The project I happen to be looking at is a fan coil system, but regardless, a VAV system or any system would have these similar loops by default. A cooling loop that shows the building's cooling peak, and a heating loop that shows the building's heating peak. And if I move over to my one that has notes on it, the two numbers I've highlighted here would be the chilled water max peak cooling load, which for this building is almost 6,000 kBTUs. Converted to tons is about 500 tons. The number below that is the number of a cooling tower, assuming some efficiency on a chiller, so some kilowatts per ton of heat is being dumped from the chiller into the condenser water loop. And that is an assumption IES makes that we can change, but if you need a quick number for a cooling tower, you could just pick that number to run with, but it's worth checking. On the heating load, we can see our building is just over 3,000 MBH or 3,000 kBTUs. By default, IES will recommend two equally sized boilers matching the peak load. The software can specify upsizing those boilers, so if you would like to always see the boilers sized at equal parts of 75% of the load, that would correspond between the peak 3,000 and the size down here 1,500 each. If that factor was applied, these would be larger. So this report is really the best, right, for the building's total cooling, the building's total heating. You get a very quick sense of what's the tons, what's the heating load, and already you can take 500 tons, take the square footage from the model, and get a square foot per ton to sort of check against instincts. The next report I want to jump to is the systems report for the entire building's primary air handling unit, which in this building is a dedicated outside air system that serves fan coils. But really what I'm looking for is trying to understand what is driving this 500 tons. What is the breakdown of the solar gains, the internal gains, and the ventilation air, and do those all make sense given my knowledge of a fairly glassy building and a fairly high load for an office space user. So if I actually skip through some of these room checksum spaces, which are good to look at, but again, if we're looking for a quick number, I already have some annotations shown here on this PDF. We're going to come down here to the systems loads report, and for this design job, there's actually only one system. Other projects potentially could have multiple air handling units, and it would be good to look at each one of those, since each one will sum up to the total cooling coil and building cooling peak shown on that second page. But for my building, I only have one air system. So similar to other loads reports you have seen, there is information on the right-hand side related to the areas of the building that were input into the model, the temperatures of supply and return airs, the airflow rates, some checksums. Other reports we see the cooling coil peak and the space coil peak here, the two different runs, ventilation sizing at the bottom, and then heating in this middle section. Very similar to other reports that come out of other peak load softwares. So things I want to look at again is what is the breakdown of my 500 tons, I'm primarily looking at cooling, attributed from my envelope, my internal gains, and my fresh air. So for this fan coil dedicated outside air system, each one of these little boxes shows when that component of the system is at its peak load, so it can be sized to its appropriate needs for either a fan sizing or a coil sizing. So this one here, for example, is the coil peak, is the zone cooling coil peak, which actually I believe may not be, I think it's the coincident peak of the fan coils, which is, it's still useful for our goal. If we're trying to understand what is the building's peak load driven by. So if we look in here at the envelope gains, and I'll touch back to why it may not be the exact time, but I think it's about the same coincident time. So already I can see this peaked in the 7th month at 4:30 in the afternoon. The outside temperature was 90 degrees dry bulb and 68.9 degrees coincident wet bulb. The envelope gains, walls, roof, ground, doors, window conduction, solar gains. So we can see solar gains are 41% of my load, 821,000 BTUs. So of the envelope gains, we can actually see internal building gains and losses. The ceiling, which was absorbing a lot of heat, released a lot of heat on this hour. So the mass of the building that was building up heat is now releasing heat back into the space at 4:30. So the envelope gains overall, I've converted to tons, 164 tons. The internal gains, lighting, people, computers, and equipment, if we wanted to, this is 124 tons for all three of these. Another good thing to check sometimes, you can take these BTUs, turn them into watts, divide it by the square footage, and you can start to see the watts per square foot of the whole building. Moving down below, the mechanical gains and losses. This is a fan coil system, so you can actually see the fan coil cooling elements themselves, room units, -2 million BTUs. And so this little box is less useful in our search for what drives the building's peak. It's sort of telling us the sum of the fan coils, which is kind of useful. It's then saying how much heat is put off by the fan. But let's not get lost. I think the main thing here is the envelope gains, the internal gains. And then if we move down to this lower box, in the dedicated outside air system in IES, we can actually see the ventilation load, or what is close to the ventilation load here. So this is saying the ventilation load is about 219 tons. I say about because this is the load to take all the air that's coming into the building from the outside condition of 93.9 degrees, which is slightly warmer than when this element peaked, down to 60 degrees. And that difference actually between these is more than the ventilation load. If ventilation would just be bringing air to neutral, which would be closer to 70, 75 degrees. So either way, if we actually added these up, it's 507 tons, and the building peak on page 2 was 496 tons. So they're not exactly the same, and that's because each one of these numbers is reporting a slightly different hour when that element was hitting its peak. But for the sake of a quick quality check, we can see the magnitude is about right. 500 tons is likely driven by 120 on the internal, 200, 220 on the ventilation, and the rest is driven by the envelope, half of which is from solar gains. I'm going to skip over heating at this point because this is a fan coil system and this little report is not super useful. You could at least see the envelope losses and put those into a BTU per square foot of the building to get a sense if that is within line with what you would expect. Things I've highlighted, we can see here the room is balancing at 75.5 degrees. That looks right. The other one I've highlighted here is the amount of outside air, which right now is at 0.26 CFM a square foot. That seems a little high to me. It could be 0.2, 0.15 would be the lowest. But either way, I think this is about right. It's about what I would expect for a building. The rest of these pages are the individual room loads and their fan coils and what drives the size of that fan coil. I would, at this point, not recommend going through these if I am only checking the whole building's load. The pages I did skip over would be a faster way to check each room to then pick out the problem childs to review. And so really quickly, what do I mean by that? So these load pages 3 to 5 in this report, have each room line by line by line with a few results and checksums to look at, both in a BTUs a square foot load you can check and the cooling CFM a square foot. This is a fan coil system, so I'm going to look at CFM a square foot. And flipping through this, we can actually start to see most of these, the peak ones are at 1.4 CFM a square foot on the perimeter. That's a west perimeter. That makes sense. That could be maybe a little less, but anything over 2 CFM a square foot would be alarming to me. And I actually found one earlier today, but I haven't dug into what is driving that room. So if we kind of go through this list, it's again a very high level, quick, where might a problem be? Here's my 2.5 CFM a square foot. So it's at least it's a south office, perhaps it's a perimeter, perhaps it's a corner, but that might be one I check and look at the breakdown of what drives that load so high. All right, so again, if we now go back to my marked up one, we have total cooling loads. We go to page 6. Things to check on the system loads again and recap: check the time of day, check the temperature, check the solar gains, how they compare to the internal gains, how those compare to the ventilation loads. Look for the outside air, see if you have the right diversities applied. Ask intelligent questions about internal gain diversities. Maybe those should be reduced by some amount. And that's the quick check for today. Thanks.